Hello everyone, and welcome to today's video tutorial. And today we are going to have a look at the design of a power supply system that can be used to power several microcontrollers such as the ESP32 and the STM32 microcontrollers. And we will have a look, or we will have to understand that for you to power an ESP32 or an STM32 microcontroller, you have to have a voltage output of 3 V3 volts and also a current output of 500 milliamperes. And this circuit that you're going to do today will introduce such things. So let us have a look at the components, the components that we shall utilize to make this a success. The first component, we shall be powering our system from a USB port, which is 5 volts. So we shall have a USB port which will be giving us 5 volts, and this will be our input. This will be our input, and then we shall be having a capacitor. And this one we shall will be having a rating of 68 microfarads. Then we shall be having another capacitor which will be around 120 microfarads. Capacitors or capacitor. That one is correct. So it will be around 120. Then what is important in this circuit is the IC, integrated circuit, and this one will be LM2594 and this one will be giving us 3.3 volts as the output. So it's you can call it, it's a voltage regulator which takes an input from an input up to 60 VDC. So another component we shall be using is we shall have a diode or a diode. This diode we will be using the Schottky type of diode. So it's a Zener diode. And then we shall have an inductor which shall be having a rating of 100 microhenry. And this inductor can be coiled inductor, and it's SMD. This one is SMD, and electrolytic type of capacitor. So another component we shall be having is the output terminal block. So I can choose to use the screw terminal block, or I can use JST connector and many other types. So that's all we need for this project. We only need 7 components. And apart from that, we shall be having ground to ground all necessary terminals. So our output, we shall be expecting to have an output of input will be 5 volts, and then our output will be 3 volts and 500 milliamperes, or you can convert it to 0.5 amperes. Yes, that's correct. So that's all we need for this project, and we will start building our circuit as quick as possible. Let's get started. You open the KiCAD area there, then you come to File, New Project. You can save it where you want it saved. Like for me, all my files are saved. Desktop. To desktop, you go to save them in article, new. Then I'll open another folder here and name it power 3v3 power supply system. Then I can open the system. Then this one I can save as 3v3 schematic. Save. So you start with the schematic. You will go to component placements. You go to component placements, and I can show you place all the components that are needed for this project to be a success, as we have discussed. So let me check on something to do with settings. Not going to stop. My mouse so that the project can be done easily. But don't lose my mouse. Sorry for the delay. Okay. I have the mouse in motion, so I'm set to go. So it's very easy to use a mouse than to use the normal laptop keyboard. So we start by placing our components. The hotkey for components is A. So you press A. You press A, you see something like that. So you start placing your components. Yes. So that's all. You start placing your components. The first component is USB port. You search for USB port, and you want to use USB. This one is 3.0. This is USA. You have USB B connector. You can try to check at them. You can check at them. You can check. So USB 3 connected. You can try to check at them. Yeah. You try to confirm the type of USB that you want to use until you get the correct one. That is USB-C. So we have different types of USBs in the market. USB connector. This is OTG, USB-B, and USB connector. can take this one and we place it there. Control save. Yeah. So you go to the next component, which is a capacitor. Cap. And then I will use American symbol small. Correct. Take the one that is polarized. Place it there. Go to the next symbol, but you can finish up the connection for this one. So to connect, the hotkey is wire. You wire your system like that. You can enlarge it. You can enlarge it. You can enlarge it like that, and we can move this one. Move to a closer destiny. You can delete the wire. You can delete the wire too. And then you can come and pick another one like that. You can control save. So we have it like that. Then you can ground this. So you can go to A. You place ground. Ground. G and D for ground. You pick the symbol. You come and place it there. You can copy it. You place it here. Then you can go to wire. Like that. Like that. Control save. You can ground this one. Like that. Control save. So you can go to the next bit. You can change the value for this one. So the value will be the value is 68 microfarad. 68 microfarad. You click OK. You have your a capacitor well represented. Now you can go and press the next component, which is our IC. We have our IC, which is LM2594. LM2594. You can see it's becoming very simple. 94. And then we have 94M. Then you select it, which is here 3 volts. So this one is correct. You place it. Okay. Like that. You control S to save your document. And then from power, you take wire. You do the connection. It goes like that. Control save. Then you ground. Copy ground. You copy C. Is the hotkey for copy. You ground this 5. Escape first. You ground the 5 like that. Then you ground the normal ground, which is 6, pin number 6, like that. Control save. We don't need some pins here, so pin 1, normally closed pins, you don't need them. You can ground them like that. Correct. We go to the next stage where we need to add our Scotch diode. Key diode. Like that. You place it. You can see it's not well placed. You can rotate this one by using the hotkey R to do the rotation. Then the Scotch key is connected from pin number 8. So you take pin number 8 wire. It goes to the our Scotch diode. You can control save. Like that. Then we have our inductor. So we can place our coiled inductor. The inductor is here. Yes. Like that. So you can place wire. Control save. So this how our project looks. So we are up to this point for the inductor, and you realize that at the end of the inductor there is a connection of these 4 here. It goes like that. comes back. Let's connect it there, just like that. Control save. So you can check the values of our inductor, as you have noted before. So V is the hotkey, and the value for inductors is 100 microhenry. UH. Okay, like that. Control save. And then you have a capacitor. So we have a capacitor. So A. Then you have cap. But this one now, the capacitor we are going to use is not polarized. So it's an polarized capacitor, small, like that. You place it there, like that. Then you can connect the wire to that point. And this capacitor of ours, it has a value. So you go to V, is the hotkey for value. The value is 120 microfarad. You hit OK. So you have the value. And then now we have our final part, which is the connector. You place it. So you place our connector. So you search like this. So 01 times 02. Like that, times 02. There's a connector you're going to use, correct? So our connector faces the right direction. You place it like that. Control save. Then now you take the wire. Then you place it there. You connect. And then you can pick on the ground. So for ground, you copy the hotkey is C. You copy again ground to this point. Then you copy the final ground to this point. Then wire, you connect them. You ground all these components must be grounded. Now we are dealing with DC current and the DC voltages. So this is our schematic. That's somehow how it looks like. This is all we expected to get. So we can ground our we don't need this and this. So they can remain like this. Control save. For now we don't need them during the design of this circuit, but in future I'll show you what the importance of this D plus pin and D minus pin, that's pin 2 and pin 3. I'll show you how they are used and the importance. So some of you might be asking themselves, where are we getting this circuit from? Or how do we know that this is the right way to connect this IC? So I'll show you in a hurry how to do it. You know, I always like sourcing my components from PCB. So I'll show you using PCB parts search. So we search from the Google. Let it search. It's taking some time. The internet might be slow. It's connected. Let's wait and see what we will be getting. Okay, if this part is delaying, we can use the DigiKey. So our IC is LM 94 M. So LM 25 94 M. So we can try to search there as we wait for the other bit. Yes, PCB. I don't want to fabricate. So we want to go to library parts and see. We see what we shall be having at PCB. In the meantime, DigiKey is also searching. So let's see what PCB will give us. Oh, my internet is very slow, but we'll be working very well. So then we refresh it. Then we see what is not happening with my internet. Disconnect. I connect. Let's see whether it shall be a bit faster. I want to use a PCB DigiKey is already working. So you have this one, you can check in stock, those that are in stock. You can check those that have the datasheet, because you know all that schematic is in the datasheet. So you have to ensure that you have the datasheet in place for you to work nicely. This one is proving stubborn. So component library parts. You can try this one. The network is busy. Try again later. The network busy. So for the PCB, it's proving somehow difficult. So we can try it work on DigiKey. Again, the network is proving somehow very busy. Okay, so datasheet. We want components that have datasheet. For it to be easy for us, they must have a photo. They must be compliant to environment rules. Normally stacking, they must, and then they must have an EDA model. So then we apply. Okay, we shall see what they will give us. We shall see what they will give us. So let's wait and see what we get. Yeah. Let's see what we get from this. So you have datasheet, you have photo, you must have normally stocking, comply with environment, such on. I like the LPSB because I will manufacture my part. So you can see this is what you are getting. It's from Texas Instrumentation. So LM94 Texas Instrumentation. I can try again to search HG saving. I can try to search it in a bit, in a different way. I know the see that one, the GST code 6691, 6691, 6691. So let's see what we get from them. This only have the data sheet. Let's download it and see what it will give us. So I'm trying to show you how you should be getting your circuits. Sometimes these ICs, they come with the data sheets, and those data sheets are very important because the manufacturer will describe to you what you need when you are checking at the data sheets. So examine. So this is what we need. So you can check out the data sheet is here again. There we see. So these are similar ICs but from different manufacturers. So this is from Examine. For Examine, this is the data sheet for the IC. As you can see, what I'm using, this is where I got my circuit on how to connect my IC LM2594. You can see the circuit is here. And then again, that one is from Hexami manufacturers. Then you have this one from Texas Instrumentation. Again, we have the data sheet from Texas Instrumentation. It looks like this. So again, it's almost a similar thing. Now this one is from Texas Instrumentation. You can see. So that's how you look for your data sheet. So you can continue with the circuit. So you can see where I got this circuit of mine. But again, this circuit of mine needs support. We said that we need 5 volts. So I had to look for this one, a USB port, which will power 5 volts into my circuit. Then you have the connector. This connector we shall be using either JST, or we shall be using other types of connectors like terminal blocks or screw terminal blocks. Also is another type of connector. So after the schematic is done like that, we can annotate our schematic. You go to annotation, which is here. You click annotation, and then you close it successfully. See, annotation complete. then you close it. Annotation is labeling this. This one is J1, this one is J2. But previously, okay, let me go back. You see how it looked like? No, you cannot go back. So previously you could look at the components, and let me place another component. We see how it looks like. You can take the small capacitor. You see this component, the C here has a question mark. So annotation is giving this C a value. For example, when you change it, this one is C1, and then you have another one as C2. So we are labeling the components. That's what we mean by annotation. So Control C. How to delete the components? I have just highlighted it and pressed the hotkey delete in your keyboard, and it will disappear. So Control C. So we have done the annotation. I want to show you how to name this schematic. You come to view, not view. You come to place. You go to graphic text. Then you place your text. So I can name this one. This one is 3v3 power supply system for ESP32 and STM32 powering. You can see you can make it bold like that. You choose whatever you want here, then I can place it wherever I want. That's how to label. And then you can add so many labels that you want. Like this one has been prepared by me, and I'm saying one Munywa Bogo. So you can place it, and I can write it in italics. I don't want this one to be so big, so text size can make it 0.8. You see how it will look like, whether it will be very small. Yeah, exactly. Then I can place this one at a corner here. I can Control save it. So this this designer. So I can even edit it and put designer like that for it to look more pretty, like that. So I'm the designer. And then we can, after annotation, you can check, do the electrical rule check, whether you have violated. I can close because I have noted we have violated several rules. So I can move this copy. Now I can move by hotkey M for moving. Then I can add wire, W for wire, like that. Control save. Then again, I can try to check at the rules. So power flag, we have said that this one is being powered. Okay, let me check the rules first, and then we see what next. So you can run, close. So you can see this one has disappeared from here. Now it's here. This one totally disappeared. So you have this one and you have this one. So what you do for these ones, you can see they are normally connected. But to end this one, what you do is quite simple. They're quite simple. You add a power flag. So you come to component, you add component, you add power flag. This is the power flag here. Okay, you can rotate it. So R for rotation. It's R for rotation. Yes, R for rotation. Then I can place it there. I can copy it. C is the hotkey for copying. Then I can place it there. Control save. Let's check the rules again. We see whether the errors will be there. We run. Finished. You see, error list 0. Total 0. Warning 0. Errors 0. So you close. So your schematic is complete. You can Control save. Now we are at another level where we need to add some footprints to our schematic. So you place this point and you let it load. We want to add some footprints there to give our schematic and okay to proceed now to PCB layout. So footprints are very important because they will guide you, or they will make your schematic now appear in the PCB layout windows. So let it load. It's taking quite some time, but it will be fine. Let it load. Correct. So here we go. So you can see this bit is empty, but LM2594 3.3 volts has the footprint package already, which is given to us. So we want to change. The first thing is the capacitor, 65 microfarad. So our capacitor is SMD. We will use electrolytic. Then you have to use the other capacitor. It will be SMD, but I want to use different types of SMD. So I'll use 012. No, we want to use 1206, 1216. This one, I like using that one. Then for USB port, so I have to look for the USB port. It's a connector. So let me check at you. No, sorry. So this side, you. No, you. So it's a connector. So USB connector is here. Then we have to check at the USB that has the 3D object. This one is empty. It has no 3D object fully. We check to ensure that you're pitching the correct thing. This one is empty again. Come here. Empty. So everything seems to be empty. Don't think so. Must be getting one. Empty. You have only footprints. So preferred file. Check in. Empty. So there is nothing with the USB. Still empty. Still empty. Empty. So there is no problem. What we do, we just add the USB connector of our footprint, and then for the 3D part, we shall be adding it at another level. I'll show you how to do it. In fact, it's a good thing. For the Scotchy diode, it's not added. So you come this side and then you select diode. Diode SMD. Then I take my diode, which is this one. Connector. This one I'll pick a different type of connector. I can decide to let me set the JS channel. Let me set the child certificate. ADC Molex. Phonics type. Let me see the phonics type, how it looks like. Correct. Let me pick this phonics type connector for today, for that system. And then you have the inductor. So inductor again, we can go to I, and the inductor SMD. So I'll go to my type of SMD, which I'm using. I'm using 12, this one. That's all. Now you have a footprint syntax. You click OK, and then you proceed. And then you check again on the electrical check. You can go back, confirm. Yes, finished, correct. Footprints, correct. Generate your net list. It's another level. You save. Net lists are very important because they will help you now to place the schematic and the footprints in the PCB layout level. Then BOM, you can generate it for now, or you can generate it later. So you can generate it. Success. You can close. Then you go now to PCB layout. That's our next level. So far so good. And in the PCB layout, what you do, you place the components. You update your PCB, you see 0 warning, 0 errors, so you update it. Then you close, then you place it like this. And now you expand your schematic. And control save. So you can move this one. This one is our PCB port. Yes, like that. Then what is very important is our connector. You can move again the connector a bit like that. Okay. Then this is what is important, which is our IC. You can move it somewhere in the middle like that. And then now you can move these ones to surround the IC. This is Jacob. Then we have the other one is the capacitor C2. You can move it again here like that. This one you can move it a bit on this other side like that. Then you can take this one and move it to the final bit. Like that. Then you can move it a bit. Like that. So move this one. Move. Like that. So we can try to observe the 3D view of this object. 3D view is it? This object. This is how it will look like. This is how our circuit will look like. But we don't have a footprint for the the USB port. And for this one, it's not a must even use a USB port. We can still use a pin like this one, but we make a note that it's powered by 5 volts voltages. So for now that one is not necessary, but at least you can see how our board will look like. So we can proceed to routing of this board. And root, you come to this root, you start routing like this. You can change this one to, you can edit, I'm showing how to edit the track size. So you can add a track size here. This one can be 0.78. Then you can click OK. Then you can come here and select it. You have added this one, track, another track. So we check, we start to that. Like that. That's first track, second track. We go like that. Then like that. Let's connect and Control-C. You go to the other one, like that. Now you straight, like that. Like that. Then you move. Then you move. Like that. Then you move. Like that. So you can see the way I'm trying to do the routing. This angle is not 90 degrees. I'm trying to make it 45 degrees. A 45 degrees angle is more stronger when it comes to PCB tracks matching. So ensure that all your tracks make an angle of 95 degrees. Yeah. So this one can go straight. If they are not straight, if you make any turn, it should be 45 degrees, not 90 degrees. So we move from here. You can see that track. Let's move. And then you do this. Like that. Okay. Another connection like this, somehow straight, like that. Like that. Like that. Like that. Okay. You try to make all of them look nice. Look nice. Like that. Control-C. You you go to the next track, straight, you try to bend it. Like that. Not really. It can't go that way, so you try to come back. So you try it again. Like that. Control save. You go to the next one, this one. You see now here, there is a problem. You cannot make a track that goes through that point because you have already another track there. It cannot allow you to go. So you can go this direction again, you cannot go anywhere. So for you to succeed in this one, you press V to place a via. So you press V. You can do like that. And then after placing the via, after placing the via, you can go back straight. Straight to the point. Then you can see V for a via. You can place the via there and then no pick. V. Via. Like that. Like that. Control save. You go to the next part. Yes, you go to the next part. Like that, control save. Then you go to this bit. You can see. Again, you need to place a V. So this V, I don't know where I'll place it. I can place it immediately there. Then you can take V. It goes to the bottom layer. Like that, it comes to the straight. Put 5. Like that. Connected. You go to the other one, which is this one. It can go nowhere. Again, you need a V. So you go to V and place it the V there. Like that. Then you go to V. Like that. You place a V. Just like that. So there is not any single track that has been left out unrouted. So we have done the routing of all the steps, as you can see. Now let's try to view the 3D view of this object. So you can see from the 3D view, now you can see the tracks. Even at the bottom side, you can see the tracks that have been made possible. And now what we do is that we want to make the edge cut. So you select the layer for the edge cut. You can take this one to measure for me. Then you select this one. So our edge cut should be somewhere there. Okay, like that. You select this one to help you do the edge cut. Like that. You come to this end like that. Okay, like that. Okay, like that. Then you go to this end and then like that. Then you go to this end, that control save. Let's try to view it. View it. How do you see the 3D view? Okay, wonderful. Okay, our PCB is coming up strongly and nicely. So we need to add some few things. I want to add a footprint we forgot, which is the mounting holes. So we want to add some mounting holes here. So we can check mounting holes like that. I think let me see this one. This is the half pad. Yes, mounting hole with pad. Okay. Let me place it. Oh my god, this one is so big. I can escape. Let me try again. Mounting hole. Mounting hole. This one. Mounting hole. You can search mounting hole. So mounting hole like this one. 2.1s. This is the best mounting hole I can use here. They're so big of them. Okay, we have a smaller one here with mounting hole. Okay, this one is smaller. It's better. It's compact. So I can place the mounting hole here. You can copy it and place it here too. Place it here too. For this other side. So I think two mounting holes are very important because they're good to demonstrate what you need to view. Let's see what happens. Okay, let me enlarge it. Making myself to suffer. So you can see those are the mounting holes for our board. Yes, they are good. And therefore, what we need to do again is now to introduce what you call copper pose. We need to introduce what you call copper pose. Ground. Okay, then you go like this. We want to highlight our schematic now and make it look somehow better. Yes, we go to the next layer. Still on copper pose. We can do it. Okay, ground. That's nice. Can do it. Yes. Yes. Like that. And then we can control save. Then you can go back to the 3D viewer and see what is happening. Enlarge, you can enlarge, you can enlarge, you can enlarge. Yes. Look at it. Look at it. Look at the tracks. Look at the tracks. They can be noticed. Yes, they can be noticed everywhere. Look at this one. It's a perfect one. It's a very perfect one. So these are three voltage source power supply system, and it's a very nice one. It's a very nice one. That's how it's done. So we can generate our files, publication files. You start with the drill files. You generate drill files. You close. You go to file again, you generate your files, publication outputs, footprint positions, and you see, you can see we have CSV and ASC1. For manufacturers like the JLPCB and PCB, they use CSV, so you can use it to generate again. Then you can close your files. Then you go to the next. The next one is another fabrication output footprint report. You can generate it because you need a report for the footprint. You can select the folders and so on and so on until you get the right thing. You go to BOM. BOM is very important. You can generate it, yes, and replace it like that. And then you can plot your GABA files. So you come to plot here. You select your GABA files. Everything is selected here. Check everything is in order. Drill marks. Plot footprint values. And then you plot it like that. Then you close. Okay. I think everything is done. And those files that you have generated now, you can share them to your manufacturer. To manufacture your PCB. That's our review. So you can sometimes want to change the colors of your board. You know, green is the universal power. You come here, color, solar mass color. Yeah, okay. You choose green as your color. You click OK. And you have green. So, but you can come here again to on preview. Choose color, solar mass color. But you have defined colors. This one is the obvious color. It comes with the PCB board. You pick it. So you can pick any color of your wish, depending on your client, if you're designing it for your client. That's all you need to ensure that your power supply system is working. All these requirements have been met. The output here is 3 volts at 500 milliamperes from the IC that we have picked. Thank you and keep on watching the videos.